Forensic Science Lecture 17-2, Gunpowder and Primer Residue. Bullets are propelled towards its target by expelling gases behind the bullet, and this is created by an igniting of a powder or nitrocellulose cartridge that then, as it burns, creates gases behind the bullet and propels it outward. But not all of the powder is burned. Unburned or partially burned particles are also propelled out of the barrel towards the target. And the distribution of the particles around the bullet hole can actually permit a determination of the distance between the gun or the shooter and the victim. The accuracy of determining the distance between the two varies according to circumstances on each case. There are opinions to distance that can only be given when an examiner has the actual suspect gun and knowledge of the ammunition type. If no weapon was recovered, the examiner can only state whether or not the shot was taken from some distance from the target or closer to it, because each gun shoots differently and each ammunition is going to travel differently. If we're looking at handguns and rifles, a precise distance can be determined by comparing powder residue patterns on the victim's clothes or skin to a test fire made at various distances. The test fire must be with the suspect's gun and the suspect ammunition, or the same type and make of ammunition. Due to the spread and the density of the residue, there's wide varying between weapons and ammunition, so it has to be done with the suspect gun. There are, though, numerous factors that influence the amount of residue that are deposited on the target. So barrel length, the caliber of the gun, the type of the ammunition, and the type and the condition of the weapon as well. But some of the general characteristics for distance are typically if the weapon is held in contact or within an inch of the target, they have a concentration of lead vapors around the bullet hole entrance, and the fibers around the hole show scorching and possible melting. And then there's also tends to be a satellite or star-shaped tear pattern around the hole that's left behind as the bullet enters. If the weapon is just discharged from 12 to 18 inches from the target, they tend to have a halo of lead vapors around the bullet hole. And if it was fired more than 3 feet, they usually doesn't deposit any powder residue. But it does typically produce a dark ring around the hole, known as a bullet wipe. So these are the different pictures of different distances, as you can see, around the entrance wound or the bullet hole. If we're looking at shotguns, determining the distance a shotgun was fired needs to be related again to test fires from the same suspect weapon with the same ammunition. The distance of the muzzle to the target could be estimated by measuring the spread of the discharged shot. So close up or close range, which is up to 4 to 5 feet, has a concentrated mass producing a hole somewhat larger than the bore of the barrel. And as the distance increases, the pellets are going to progressively spread out and separate. So a 12 gauge shotgun generally increases 1 inch for every yard. So they kind of use that as a gauge when they're determining the distance. Other factors, though, with shotgun wounds have factors that influence what the appearance looks like based on the barrel length, the size, the quantity of the pellets fired, the quantity of the powder discharge, and then the choke of the gun can also affect the shot pattern. The choke of the gun is the degree of constriction placed at the muzzle end of the barrel to control the shot dispersal, because within a shotgun there are pellets that are within that bullet. So these are some pictures of shotgun wounds at varying distances. Okay, so there's also powder residue on garments. And all items are examined microscopically for gunpowder residue. Okay, particles may be identified by their characteristic color, size, shape. But what's interesting is they can also be obscured by a lack of contrast between the garment and powder, or if there's a large amount of blood. And so they can easily be overlooked. But now we can use IR photography to overcome the visual problems, and then chemical tests can also be performed to identify different residues that are present in the gunpowder. Nitrates can result from an incomplete combustion of the powder. There's what's known as the grease test, and it can detect particles. The examiner transfers the particles to a chemically treated gelatin-coated photographic paper, and they do this by applying the paper onto the garment and then applying a hot iron, and then a chemical treatment to this paper reveals the particles. A second test is performed to detect lead residue that may be present around the hole, and they do this by spraying a solution of sodium rhodazonate, followed by an overspray of an acid solution, and the lead particles will actually turn pink and then a blue-violet to indicate that there is lead present. We can also identify if a gun has been recently fired. And so when a gun is fired, or a weapon is fired, it blows gunpowder and primer residue also back towards the shooter. So it doesn't only come out of the muzzle, it also comes out, or out of the barrel, it also comes back onto the shooter's hand. And so the resulting evidence is traces of the residue on the hand of the shooter, and this can provide valuable information to the investigators of who that shooter may have been. For many years, investigators actually focused on detecting unburned gunpowder on the hands of the suspect, and they used the dermal nitrate test, which was hot wax was brushed onto the hands of the suspect, and then after drying, the wax is removed and then tested with diphenylamine, which would turn a blue color, indicating a positive result for gunpowder. Today, though, what investigators focus on is determining primer residue, and that's because the dermal nitrate test is not necessarily that specific. There can be other substances like fertilizers, cosmetics, tobacco, can all give a positive result for nitrates. And so now they're looking at now they're going to look at the primer residue. And primer manufactured today typically contain lead styphenate, barium nitrate, and antimony. There's an exception to this, which is a .22 caliber ammunition that does not use any of those. But there are other tests that they'll use to help detect those. So in order to obtain that residue, examiners are going to measure the amount of barium and antimony on the relative portions of the suspect hand, which would be the thumb, web, the back of the hand, and the palm. The most popular and convenient approach is to remove particles. It is to apply an adhesive to each of those surfaces with different cotton balls, so or different pieces of adhesives to keep them separate, and then of course labeled properly. Another approach is to swab both the firing and non-firing hands with cotton moistened in nitric acid. That will help to remove that primer residue as well. The problem with primer residue is that it doesn't last for a long time. So although it can leave primer residue can leave high levels of barium and antimony levels, which is a strong indication that that person handled or fired that weapon, or at least was very near to the weapon when it was fired. it doesn't last. So it can be removed intentionally or unintentionally by washing hands, rubbing or wiping hands on shirts or objects or pants. And then, of course, like I said, if the weapon was a .22 caliber ammunition, it's not going to have barium and or antimony to detect. They'd need to do a second chemical test for other chemicals in those primers. But particles removed from the hands can be found with what's known as a scanning electron microscope, SEM or SEAM. It is linked to an X-ray analyzer, and it finds a combination of lead, barium, and antimony and confirms the particles are primer residue. The SEAM characteristic primer particles characterizes the primer particles by the size, the shape, as well as its chemical composition. This takes time, but there is an automated particle search that is being developed, so the identification system may overcome the length of time needed in order to do this. But other primer residue tests are a neutron activation analysis and a flameless atomic absorption spectrophotometry can detect barium and antimony. However, it's very expensive, and there are extensive regulations for the requirements of these machines, so it's only available in a small number of labs. This ends lecture 17-2. There's a quiz next class.